All right, question 11 on this practice test 1 in section 5. This is a pretty hard question, I think. Probably the hardest one we've come across so far. This deals with combinatorics. In the land of combinatorics, at least for the purposes of this class, there's really two big formulas to know. The combinations formula, often written NCR, and the permutations formula, often written NPR. The big difference between combinations and permutations is for permutations, the order matters. So in the context of this problem, suppose that you had to choose 2 books from a group of 5 books. If you just want to know how many ways can you select 2 books from a group of 5 books, we're talking about combinations. N is the number of books you're choosing from, and R is the number of books you're choosing. So if we're choosing 2 books from a group of 5, we'd have 5C2. In this specific problem, combinations will be the thing that we need. But maybe you can imagine a similar problem where somehow it was specified that the order matters. So like you and me both chose the same 2 books. What are these? Biographies? A biography on, I don't know, Frederick Douglass and another one on Abraham Lincoln. Sure. But you read the biography on Frederick Douglass first and then the Lincoln one, and I read the Lincoln one and then the Frederick Douglass one. In the world of combinations, we're choosing the same 2 books. In the world of permutations, we've just done 2 separate things because the order that we read the books was different. Anyways, for combinations, the formula is n factorial divided by r factorial times n minus r factorial. And you're like, what does all that mean? Don't worry about it. I'll explain it in just a second. For permutations, you got another formula, and you're like, oh, I'm never going to memorize these. Well, good news. It's almost identical. The only difference is we don't have this r factorial in the denominator. So it's n factorial divided by n minus r factorial. First question, what's going on with these exclamation points? An exclamation point in mathematics means factorial. And for the purpose of this test, just think about it as hiding a whole bunch of multiplication. If I had 5 factorial, for example, all that means is I'm going to multiply 5 by a bunch of numbers. Which numbers? All of the whole numbers from 5 down to 1. So 5 factorial means 5 times 4 times 3 times 2 times 1. Let's see, 5 times 4 is 20 and 3 times 2 is 6 and 20 times 6 is 120. So 5 factorial is 120. Similarly, 3 factorial would just be 3 times 2 times 1, which is 6. 1 factorial would just be 1. And you can go further. You can expand this definition to work for fractions or negative numbers. It turns out that 0 factorial, you probably think it should be 0. It's not, it's 1. Whatever. You don't need any of that for this test. For the purposes of this test, when you see factorials, they'll be following positive integers. And just think, multiplying by all of the integers between that number and the number 1. With all of that out of the way, I think we have enough information to answer this question. But even now, it's a little bit tricky. So we have a reading list for a humanities course that consists of 10 books, of which 4 are biographies and the rest are novels. Might be worth writing 4 biographies, and instead of the rest, recognize that 10 minus 4 leaves us with 6 that are novels. Each student is required to read a selection of 4 books from the list, including 2 or more biographies. That's kind of tricky. The test writers could have been nice saying exactly 2 biographies, but they didn't. They said 2 or more. What that means is that we need to choose either 2, 3, or 4 biographies. The question is, how many selections of 4 books satisfy this requirement? Well, I think what I would do is I would recognize that really we have 3 different cases, right? Either we choose 2 biographies, or we choose 3 biographies, or we choose 4 biographies. So I'd be like, all right, in case 1, I'm choosing 2 biographies. If I'm choosing 2 biographies and I'm choosing 4 books in total, that means I'm choosing 2 novels. How many ways can I choose 2 of the 4 biographies? Well, that's exactly 4C2. In other words, 4 factorial divided by 2 factorial times 4 minus 2, which is 2 factorial. Some handy shorthand when you're dealing with combinations is often the way this is written is as a 2-by-1 matrix, where the number on the first row is the n and the number on the second row is the r. What I'm saying is, for the sake of room, instead of denoting the number of ways I can choose 2 biographies from a group of 4 biographies as 4C2, I could denote that as 4(2) in parentheses like this. This represents the number of ways I can choose 2 biographies from a group of 4 biographies. I need to multiply that by the number of ways I can choose 2 novels from a group of 6 novels. I could write that as 6c2, or I could write that as 6-2 in this kind of shorthand notation. The reason we're multiplying these two things together is because these are two independent events. The two books that I choose from the biographies do not affect the two books I can choose from the 6 novels. So to figure out the number of ways these two independent events can happen, I multiply the number of ways this thing can happen by the number of ways this thing can happen. That probably all sounds pretty abstract, but it's not as complicated as you think, right? Think about the number of results you could have if you, flipped a quarter and then rolled a 6-sided die. There's 2 different options for the flipping of the quarter, heads and tails, and there's 6 different options for rolling the die, 1, 2, 3, 4, 5, 6. So the total number of outcomes that could happen would be 2 times 6, in other words, 12. You could enumerate them pretty easily, right? Heads 1, heads 2, heads 3, heads 4, heads 5, heads 6, tails 1, tails 2, tails 3, tails 4, tails 5, tails 6. Really what I would be doing is 2 choose 1 and 6 choose 1. I'd have 2 options, heads and tails, and I'm choosing one of them. And I have 6 options, the numbers 1, 2, 3, 4, 5, and 6, and I'm choosing one of them. That's not this problem, though. That's just trying to make sense of why I'm multiplying together this answer and this answer. Anyways, I think I'm at the point where I can use these formulas. For 4, choose 2. Kind of nice thing about this notation is the 4 is up on the top. I get 4 factorial up on top from this formula, right? N here, N here. The 2 is down on the bottom. I get a 2 factorial down on the bottom. But be careful, you're not done at that point. That's just this n factorial and this r factorial. You also need to figure out what is n minus r. What is 4 minus 2? Well, 4 minus 2 is just 2. So I have another 2 factorial down here on the bottom. You could figure out what number this is equal to if you want, but we're going to have to take that number and multiply it by the number that represents 6 choose 2. So maybe it makes more sense to write this one using this formula. 6 choose 2, there's a 6 up on the top, so I got 6 factorial. There's a 2 down on the bottom, so I have 2 factorial down on the bottom, but then be careful, you're not done. Right here, I need to figure out what is 6 minus 2, 4 in this case, and write a 4 factorial. There's lots of multiplication going on here, but factorials work out kind of nicely with multiplication. First thing you might recognize is there's a 4 factorial up on the top and a 4 factorial down on the bottom, so those guys are gone. That leaves me with 6 factorial divided by 2 factorial times 2 factorial times 2 factorial. Well, 6 factorial is just 6 times 5 times 4 times 3 times 2 times 1. You don't even have to write the times 1 if you want to save a little bit of room. And 2 factorial is just 2 times 1 times 2 factorial, which is just 2 times 1, times 2 factorial, which is just 2 times 1. Rather than multiply this across, I might recognize that I got a 2 on the top and a 2 on the bottom, so those cancel. And then I have these 2 2's down on the bottom, which can cancel with this 4 from the top. So what I'm left with is just 6 times 5 times 3. 6 times 5 is 30, and 30 times 3 is 90. You're like, oh, whew, we're finally done. 90 is the answer. I can fill in A. No, this is just case 1, right? It doesn't say each student is required to read a selection of 4 books from the list, 2 biographies, and 2 novels. It says you must have 2 or more biographies. So there's 3 different cases: the case where there's exactly 2 biographies, the case where there's 3 biographies, and the case where there's 4 biographies. All this work was just the first case. Oh my God, this is the worst problem ever. Well, I got some good news for you. Case 2 and case 3 are going to be a little bit more straightforward. For case 2, I'm choosing 3 biographies. If I'm choosing 3 biographies, that means I must be choosing 1 novel. How many ways can you choose 3 biographies from a group of 4 biographies? Well, that's just 4 choose 3. How many ways can you choose 1 novel from a group of 6 novels? Well, that's just 6 choose 1. 4 choose 3 is 4 factorial divided by 3 factorial. Remember the number on the top, the number on the bottom, but then you're not done. I have to multiply by 4 minus 3, which is just 1 factorial. 6 choose 1, I got a 6 up on the top, I got a 1 down on the bottom, but then remember you're not done. I got to figure out what's 6 minus 1, 5 in this case, and get 5 factorial. Might look like there's a lot of multiplication here. I could rewrite 6 factorial as 6 times 5 times 4 times 3 times 2 times 1. But think about how nicely this will simplify. First of all, 1 factorial is just 1, so I can completely ignore that. And 5 factorial is 5 times 4 times 3 times 2 times 1. So if 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, And 5 factorial is 5 times 4 times 3 times 2 times 1. Damn near all of 6 factorial is going to cancel with this 5 factorial, right? The 5s are gone, the 4s are gone, the 3s are gone, the 2s are gone, and the 1s, I didn't even need to write them in the first place. I'm just left with this 6. And that's not special for 6 and 5. That works for any two numbers when I'm dividing factorials. If these two numbers are relatively close, most of them are going to cancel out. 20 factorial divided by 19 factorial would just be equal to 20. 100 factorial divided by 98 factorial would just be equal to 100 times 99, because everything else in the 100 factorial is going to cancel with the 98 factorial. Anyways, what I'm saying is 4 factorial over 3 factorial is just equal to 4, because the rest of the 4 factorial cancels with the 3 factorial. And 6 factorial divided by 5 factorial is just equal to 6, because the rest of the 6 factorial cancels with the 5 factorial. 6 times 4 is just 24. Before I move on to case 3, I want to make a comment about case 2. I've got 4 biographies and I have to choose 3 of them. Think about if you were actually doing that, right? If I gave you 4 books and I asked you, pick your favorite 3 here. You probably wouldn't think about which of those 3 is your favorite. You'd probably look at the 4 and be like, I don't like this one. I'm not reading that. I'll read the remaining 3. Instead of thinking about this as choosing 3 biographies to read, you could think about this as choosing 1 biography to not read. How many ways could you choose 1 biography to not read if there were 4 biographies? Well, you'd have 4 options, right? You could not choose the first one, in which case you're choosing the second, third, and fourth. You could not choose the second one, in which case you're choosing the first, third, and fourth. You could not choose the third one, in which case you're reading the first, second, and fourth. And finally, you could not choose the fourth one, in which case you're reading the first, second, and third. Sometimes when you're doing these problems, it can be beneficial to think about the way you're choosing something is by not choosing something. In this specific case, if you wanted to, you could probably figure out that 4 choose 3 is equal to 4 without doing any of this math. This 4 right here just represents the 4 different biographies that you could choose to not read if you have to read 3 of the 4. Similarly, we could probably skip all of this math here. If you're only choosing 1 novel and there's 6 novels, you probably don't need to write 6 factorial divided by 1 factorial times 5 factorial. You could just be like, wait, there's 6 novels, so I have 6 choices. This is clearly going to be a 6. 4 times 6 gives us our answer of 24. And maybe now you're thinking like, wait, why didn't you lead with that? Why did you bother telling me all these stupid formulas that I'm never going to remember on test day? It's way easier to just think about, I'm not reading 1 of the 4 biographies and I am reading 1 of the 6 novels. Well, because that only works in special cases like case 2. That way of thinking would not help you in case 1, where we have to choose 2 biographies and 2 novels. There's no easy way to figure out that there's 90 ways that you could do that. We've got case 1 and case 2 done. If we could just knock out case 3, we'd be done. Great news, case 3 is probably the easiest of the 3 cases. In case 3, we're reading 4 biographies, in which case we're not reading any novels at all. How many ways can you do that? Well, if there's 4 biographies and we have to read all 4 of them, that only gives us 1 choice. And we're not reading any novels. It sure sounds like there's only 1 way that we can do that. That's true, there is. What's kind of nice is that intuitive approach is consistent with using these formulas. If we had written there's 4 biographies and we got to choose 4 of them, and then there are 6 novels and we got to choose 0 of them, we could use our formulas that we have up here to come up with 4 factorial divided by 4 factorial. There's a 4 on the top and a 4 on the bottom, but then remember we're not done. 4 minus 4 is 0, so we'd have 0 factorial. And then here we got a 6 factorial and we got a 0 factorial, but then remember you're not done. We need 6 minus 0 or 6 factorial. Remember earlier how I talked about 0 factorial and I said a lot of people think that it's equal to 0, but it's not. It's equal to 1. Maybe now you can see why it can't be equal to 0. Right? If it were equal to 0, 0 times anything is 0, and I'd have something divided by 0, I'd get an undefined output here. I wouldn't be able to answer questions like this. It's a good thing that 0 factorial is defined to be equal to 1. 4 factorial cancels out. This is just 1. This whole fraction's 1. 6 factorial, those cancel out. 0 factorial is just 1. This whole fraction's equal to 1. 1 times 1 gives me this answer of 1. So finally, to get the answer to the question, we take the 90 different ways that we could choose 2 biographies and 2 novels from these books. and then add the 24 different ways that we could choose 3 biographies and 1 novel from these books, and then add the 1 way in which we could choose 4 biographies and 0 novels from these books. 90 plus 24 plus 1 is equal to 115. B is the correct answer here. I think one of the hardest things about combinatorics problems is kind of the translation of a word problem into the math. Generally speaking, when you have to do A and B, think multiplication. When you have to choose 2 biographies and 2 novels, we multiply the number of ways we can do the first event by the number of ways we can do the second event. But when you're thinking about the number of ways and there's an or in there, like we could choose 2 biographies or 3 biographies or 4 biographies, generally speaking, that manifests as addition as opposed to multiplication.